Number 5 there. Now, probably you wouldn't write it the way they wrote their answer there. All right. So we talked about, there are 3 numbers that are going to come up into my answer for a sine or a cosine where I use a sum or difference formula. Okay. What are they? Always. That's it. All right. Square root of 6, square root of 2, and 4. Okay. The 4 is going to always be the denominator. So the differences is whether sometimes they're either positive or negative. Now, do y'all understand how that this one could be, you could usually give 2 different forms of the answer by the different order of square root of 2 and square root of 6? You'll kind of get that. The order doesn't matter. What matters is the correct sign in front of square root of 6 and square root of 2. So notice both of them, both answers have negatives in front of them, don't they? Okay, that's what makes them right. All right, y'all look and check over now the bottom part, 14. All right, 14, 15, 16, 17, and 19. Okay, so somebody asked me earlier in second period on number 14, they asked me, could I write that as negative square root of 6 plus square root of 2 over 4? Would that be okay? Yeah, okay, because the square root of 6 is negative, the square root of 2 is positive. That's what matters. The order is not necessarily important, okay? Because you're going to get, you know, according to which 2 angles that you use and what order that you put them in, you might get a different order from what somebody else gets.
And these 3 numbers are only for sine and cosine.
Right. All right. Tangent, you're going to get basically just 2 numbers, okay? But we'll get to tangent in a minute, and I'm going to warn you, tangent is pretty nasty, okay? It's very, very nasty, okay? Somebody also said that we should vote tangent off the island. Let's just not do tangent. Well, I'll put it to you this way. I'm not making you do secant, cosecant, or cotangent, okay? So, and the reason why is because they don't make you do it in college trig. They only make you do sine, cosine, tangent in college trig, okay? But that would be a good bonus. It would be like secant, cosecant, or cotangent. Sure. All right. We'll look at 17. All right, and 19. Okay. All right, let's look at 17 then. And my pen's not working. Do that. All right, you gotta do the sine of pi over 12. Okay, now with it being in radians, it's kind of hard to come up with 2 angles in radians that add or subtract to pi over 12. So what can we get around that? How can we get around that? Degrees. Okay, so did y'all get in terms of degrees here that pi over 12 is 15 degrees? Okay, do we need an explanation? Okay, so we're just changing it to degrees because it's easier to come up with 2 numbers that add or subtract to give me 15 than it is. Okay, so let's look how that works. All right, remember how we convert it here? So we say like pi over 12 radians, and we're going to change it to degrees. Now we put, what do we know about pi radians? Pi radians is equivalent to 180 degrees. All right, and now, so pi radians would cancel out. Now that's not 12 times 180, that would be 1/12 times 180, and that would give you 15 degrees. Okay. Now, with 15 degrees being so small, you're not going to find 2 angles on your unit circle that add to be 15, are you? So you're going to have to use the difference formula. Okay. So there's lots of angles that are going to subtract to give you 15 degrees. So let me copy down the formula and let you guys think about the angles there. Bless you. All right, let's look over there. So sine of A minus B is sine A cosine B. And then minus, what is it, cosine A? I don't know them. I've taught this for 4 years and I still okay, so it's really hard to learn. Now, so let's come up. What's two angles here that could subtract to give me 15 degrees? Lots of them. All right, 45 and 30 would work. Okay. What about 60 and 45? Okay. All right. So, all right, somebody pick two. Which ones do you want to use? All right, 45 and 30. Okay. We'll do 45 and 30. Probably should write them here first. 45, 30. All right. So let's see. Sine of 45 would be square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. And sine of 30 is a half. Did I get them right? Because I didn't look at my unit circle when I did it. Yeah, I've got them memorized. Okay. All right. So now let's multiply it out. So square root of 2 times the square root of 3. Can I actually multiply that? Yeah. Okay, so that would be square root of 6 over 4. So let's talk about this. We were multiplying that, right? Now, it's okay to multiply the radicands together. All right, what about it when it comes to adding and subtracting that? No. Okay. All right, let's bring down this minus. So square root of 2 times 1, 2 again is going to give me 4. Now, can we start skipping this middle step right there? Okay, because it's always just going to wind up over 4. All right, so we'll get square root of 6 minus square root of 2 over 4. All right, let's say what's another way that I could give that answer and still be correct here? You could say negative square root of 2 plus square root of 6 over 4. Okay, that would be okay there too. All right, which other ones? Number 19. Okay. All right, on 19 we've got the cosine of negative pi over 12. Okay, so we notice that it's negative. Now, you remember our even and odd properties? Okay, let's go back to that. What do we say about like sine if the angle is negative? Right, so this would be negative sine x. Okay, now this one was cosine though. So this one, well, we say that what sine is odd, but what about cosine? Cosine is even. So cosine of negative x is just cosine x. Okay, so the cosine of negative pi over 12 would just be cosine of pi over 12. All right. Right. Cosine and secant are even, and then the other 4 are odd. Right. Mm-hmm. Now, I know my pens aren't responding. I got to do all this. I got to get a bigger eraser than that. Oh, that's a big one. Covers a lot. So I can just do away with the negative sign. Okay, because cosine is even. Okay. Now, we just said in the last problem that we did that what pi over 12 is what 15 degrees. Okay, so let's write it as cosine 15 degrees. Now, since 15 degrees again is so small, I'm going to use a difference formula. So I'm going to use a cosine of A minus B, okay, which is cosine A cosine B plus sine A. Now, Y'all just want to use the same two angles that we used last time, which was what, 45 and 30. Okay. All right, cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 40, and then sine of 30 is a half. Y'all check me on all those. Okay, so now that's going to give me what, square root of 6 over 4 plus square root of 2 over 4. Can we shortcut that now? And just say square root of 6 plus square root of 2 over 4. All right, what's another way I could do that? Right. Square root of 2 plus square root of 6 over 4. That would work too. Okay. All right, and remember how we can check them on our calculator. Okay, punch in cosine of 15 degrees, and then punch this in. It should be the same thing, the same decimal value. All right, what about, I said one more. What was the other one? Okay. All right, now let's do this. I'm gonna kind of go back on something. I'm actually going to teach you how to memorize your sine and cosine for these sum and difference problems. Okay? Now the only stipulation is you're still going to have to show your work. Now the reason why we'll show you this is for the purpose of tangent. Okay, so let's do this. You probably want to do this with me here. We're going to look at a unit circle. And what we're going to do is we're going to look at all those angles that I could get with sum and difference. And basically what the angles that I can get with sum and difference are 15 degrees inward from each axis. Okay, so I'm going to start, and I'll try to color code it for you. I'll do, those are my main three, right? Okay, so let's do those in each quadrant. Now we're not going to label those, okay? Let's just put them there so we can have a reference. Now, let me get my different colors going here. Yeah. How do I make my pen color different? Oh, never mind. Here we go. All right. Now, the ones that you get with sum and difference, again, are 15 degrees inward from each quadrant. Okay, so we're going to be talking about this one, 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 and this one. Okay, so that'd be a power over 12 in terms of radians. Okay, now, so this one is going to be 15 degrees. All right, now, y'all imagine what this one's going to be up there. That's 90. So, right, this is going to be 75. Okay, again, that's 90. So if I go inward 15, this would be 105. Right, that's 180. So if I back up 15 degrees, this one's going to give me 165. Okay, that's 180. And if I go, again, inward by 15 degrees, that's going to be 195. Right, that one's 270. So back up 15, that's what, 255? Y'all check me on that. Is that right? 270 back 15 would be 255. All right, and then 270 and go forward 15, and that would be 285. All right, now let's go there. That's 360. If you go back 15, then this would be 345. Yeah. Okay. Now, I'm going to show you how you can memorize sine and cosine. Okay. All right. The cosine, now y'all think about this. That's a pretty good x distance, isn't it? That's pretty far. Now, what are the same old numbers that we keep getting? Square root of 6, square root of 2, and over 4. So what would give me the longest distance with those two numbers, square root of 6 and square root of 2, if you do what? if they were both, right, added, if they were both positive. Okay, so square root of 6 plus square root of 2 over 4. Now, on my y value, I think I just found this one. Hang on, we did, I think, the sine. Yeah, okay, we did. And so think about it. That distance is not very tall, is it? Okay. Now, so I'm going to have to subtract them. Now, if I did square root of 2 minus square root of 6, it would be negative, wouldn't it? And that's not going to be negative. So see if you can figure it out. It would be square root of 6 minus square root of 2 over 4. Okay. Now, really and truly, to get the sum and difference ones with sine and cosine, those are the only two you have to really memorize. Okay. Square root of 6 plus square root of 2 over 4 and square root of 6 minus square root of 2 over 4. Now, think about what happened when we did this angle and this angle about their ordered pairs. What was the relationship, the pattern in that? Yeah, they were switched. Okay, so 75, all we're going to do for 75 is just take these two ordered pairs, switch them. All right, yeah, so this one's going to be square root of 6 minus square root of 2 over 4. And then the y coordinate would be square root of 6 plus square root of 2 over 4. Now, think about this, and you could probably figure the rest of them out. How can I get the rest of them? Right? How can I get like 105 and 165? Yeah, the reflections. Okay, so I can reflect 15 degrees to get 165 degrees, right? Now, what would change that? The x would change. We would change the x's to a negative. Now, so we would change this one. Now, it wouldn't just change the square root of 6, it would change both of them, okay? So on 165, this would be negative square root of 6 minus square root of 2 over 4. Now, would anything happen to the y? Would that sign change there? It's going to be the same thing. So that would just be same thing, square root of 6 minus square root of 2 over 4. All right, now let's do 105. So again, on 105, what's going to change there is just the x one. So just this one. So what would that change to then? All right, negative square root of 6. Did y'all say plus? All right, plus square root of 2 over 4. And then the y one doesn't change. Square root of 6 plus square root of 2 over 4. I think I need to be like 2 inches taller, and that would be perfect for me. Get there. All right. Yes. Mm-hmm. Yeah, that's a minus sign right there. Okay. All right. Now let's reflect them down here. So what can I reflect to get 195? The 165. Okay. So what's going to change though when I reflect that? The y's. Okay. So the x wouldn't change, would it? It's still going to be negative square root of 6 over or minus square root of 2 over 4. But then this would be negative square root of 6 plus square root of 2 over 4. All right, let's do 255. So what can I reflect to get the 255? 105. All right, the x is going to stay the same. So it's still going to be negative square root of 6. All right, and then plus square root of 2 over 4. But now we're going to change the y's. So y'all tell me what the y's are going to be down there now. Square root of 6, all right. Square root of 2 over 4. Okay, that's a minus sign right there. All right, 285. Now, we could reflect 255 to get 285. What else could we reflect? 75. Y'all want to do 75? All right. So what's going to change there? Just the y, because you're reflecting across the x-axis. So this is going to stay square root of 6 minus square root of 2 over 4. And then the y would be negative square root of 6 minus square root of 2 over 4. All right, at 345, yeah, so the x is going to stay the same. So square root of 6 plus square root of 2 over 4. And then now this is going to be negative square root of 6 plus square root of 2 over 4. All right, so yes, that was fun. Now, here's the stipulation. You still got to show me how you get those, okay? But you can memorize these, and this is especially good for finding the tangents, okay? So now, let's start in on finding my tangents now, okay? No, tangents is not really going to be, say, who said yay? Yeah, it's not really going to be yay. It's going to be like, oh, really? Okay. All right, so let's look. Oh, it was sarcastic. Okay. Yeah, that makes sense. All right, so let's do, all right, we're going to find tangents by our sum and difference formulas. Now, look at your reference sheet, and what you're going to find is you're going to actually find a formula for tangent. Okay, so you've got tangent of a plus b. Now, I would write this down, okay, but I'm just going to show you one of these. Tangent of a plus b is you get tangent a plus tangent b over 1 minus tangent a times tangent b. Okay. Now, the past 3 years or 4 years, I've used the tangent formulas. Okay. I've done some research and I found, like watching YouTubes and stuff, talking about other teachers, and there's a better way to find tangent than using the tangent sum or difference formula. All right, let's see if you can figure out what else could I do to find like a tangent of 15 degrees without using this formula. How could I do it another way? What's other ways to find tangent? Sine over cosine. Okay, so instead of tangent A plus tangent B over 1 minus tangent A times tangent B, which gets extremely nasty, okay, what we do instead here is just this. We're going to do, where'd my pen thing go? Here we go. The sine of A plus B over the cosine of A plus B. Now, it's still pretty bad, okay, but it's not as bad as what the tangent formula is, okay? And right, so this is what we're going to use. We're going to use the sine over the cosine. And if you notice, did you find the tangent formulas on your reference sheet? You can use those if you want to, okay, but I haven't had very good success with them in the past. If you notice on the left, I didn't write them on the board over there. I didn't write the tangent formulas down because I'd rather that you try using sine over cosine. Okay, now let's try one with a tangent here. Let's do the tangent of 165. Okay, or let me think about that. Yeah, we'll do that one. So let's find the exact value here by using a sum or a difference. Okay, so now, all right, do y'all want to do this? We need to find what the sine of 165 and divided by the cosine of 165. Okay, now, do y'all want to use a sum and difference formula to get the sine and cosine, or do y'all want to kind of cheat and get them off of here? Okay, so here's ultimately what I'm going to do for you. On the test, if I ask you for the tangent of 165, I would previously ask you for the sine of 165 and the cosine of 165. Okay, so you could already have them to get there. All right, so let's look back. Let's go and get let me write it out this way. Okay, the sine of 165 over the cosine of 165. Okay. All right, we could do sine of a plus b to find that. Okay, but we're going to cheat a little bit. We're going to go and memorize it. Right. Okay, so let's go with sine of 165. Let's look. So that would be, what would be the sine there? Square root of 6 minus square root of 2 over 4. Okay, square root of 6 minus square root of 2 over 4. All right, now divided by the cosine of 165, which is negative square root of 6, 65. Okay, so negative square root of 6 minus square root of 2 over 4. No. Okay, so you could always just do your sum and difference to get sine of 165 and cosine of 165. Okay, they're over there to your left for sine and cosine. Okay, now let's look at this. That looks pretty bad, doesn't it? Okay, now I want you to find something that's going to happen every time with these because you get the same numbers. If I think of this as instead of division as multiplying by the reciprocal, this 4 would wind up on top, wouldn't it? And y'all see how the 4s would just cancel? Okay, and that's always going to happen. So the 4s are going to go away. Now, that's going to leave me with square root of 6 minus square root of 2 over negative square root of 6 minus square root of 2. Okay, now because they're not the same. Yeah, but see, that's not, it's not. Okay, now, here's what I want you to do. This is basically the answer, but what's wrong with the form of it? It's radicals. Yeah, radicals in the denominator. So I'll do this for you to try to help you out because tangent is so difficult. If you will box this in for me when you do this problem on the test or a problem like it, I can give you like a lot of partial credit for getting that part of it. Okay? Because really the hard part comes in with rationalizing. Okay, now we're going to have to go back to a lot of Algebra 2 rules here to rationalize this. Now, you remember how to rationalize this? How you have to multiply not by just like square root of 2 over square root of 2 or square root of 6 over square root of 6, but you have to multiply by the conjugate. Remember that? Okay, so you remember what the conjugate is? The conjugate just changes the middle sign. All right, so for instance, let's just look at a couple just random expressions like this, okay? And let me think of another one here. So like 3x plus 2, what would be the conjugate? And 3x minus 2. So what changes is the middle sign to get a conjugate. So negative 4x plus 3 would, the conjugate would be negative 4x minus 3. And then 4x minus 7 would be negative 4x plus 7. Nope, that's wrong. It would just be 4x. Okay. All right, so remember what a conjugate is now? All right. Now, the one that we have to multiply by the conjugate here is the denominator. Now, let's remember this too before I actually do that. What happens, this kind of nice when I multiply two conjugates, like what would be the conjugate of x minus 6? All right, so what's the shortcut that we can do there when we multiply conjugates? You just have to do, it's not full, because you don't have to on conjugates. It's what? First and last. Okay. Now, if they're not conjugates, I would have to FOIL it out. All right. Now, let's look at this. Okay. And hang with me here. because I know this is pretty difficult. So we're going to multiply by the conjugate here. Now, conjugate of the denominator because that's what we're trying to rationalize. Now, what's going to be the conjugate of my denominator? The square root of 6 plus the square root of 2. So I'm also going to have to multiply the numerator by that too. So negative square root of 6 plus square root of 2. All right, now, y'all kind of look at the big picture here. When I multiply the denominators, all I have to do is first and last because they're conjugates. But when I multiply the numerators, I'm going to have to use the full method, and that's going to get pretty nasty. Okay. Now, one thing that you end up with a lot in these problems, you get the same thing over and over, just like you did with sine and cosine, is you get a square root of 12 popping up. So it's usually a good idea to go ahead and just have that simplified in your head or sort of memorize. What would that simplify to? Right, yeah, 2 square roots of 3. All right, so just remember, when we get a square root of 12, let's just go ahead and write that as 2 square roots of 3 because you're going to see it often. Now, let's start multiplying this out and rationalizing. All right, so here we go. I'm doing the full method in my numerator, so do first. What's the square root of 6 times a negative square root of 6? All right, but you need to take the shortcut. What happens when I do this? The square root of x times the square root of x. It's just x, right? So let's use that shortcut. So let's just say the square root of 6 times the square root of 6 would be 6, but with that negative, it would be negative 6. Huh? It would be positive. Okay, we'll get to one like that in a second. Yeah. All right, so there's first. Now let's do outside. What's outside going to give us? Square root of 12, which is 2 square roots of 3. All right, now do inside for me. That would be another square root of 12. So it would be another 2 square roots of 3. Now, y'all see where I'm getting it as positive, though? Because it's a negative times a negative. So we got first, outside, inside. Now last, it's going to be negative 2. All right, talk to me. Did y'all follow each first, outside, inside, last there? All right, let's go back over it then, okay? So first, what are we multiplying? Square root of 6 times negative square root of 6. Square root of 6 times square root of 6 is just 6. But it would be negative because you got one negative, right? All right, outside. What's outside going to be? Square root of 6 times square root of 2, which is square root of 12, but square root of 12 is 2 square root of 3. Okay? Inside, negative square root of 2 times negative square root of 6 would be positive square root of 12, which is, again, 2 square roots of 3. And now last, negative square root of 2 times positive square root of 2 would be negative 2. Okay? Now, the bottom part is not nearly going to be as bad because they're conjugates, and all we have to do on conjugates is just first and last. Okay? So do first for me there. It'll be positive 6. Okay? Now, in conjugates, this sign and this sign are always opposites, aren't they? So that means it's always going to be minus, yeah, or negative. Okay? And now square root of 2 times square root of 2 would just be 2. Right, now, let's clean it up. So let's see, negative 6 minus 2 will give me negative 8. 2 square roots of 3 plus 2 square roots of 3. Can I add that together? Yeah, because the radicands are the same. But we don't add the radicands. We only add the coefficients, the 2's. Okay, so that would be 4 square root of 3. Okay, over 4. Right, and you can, it is, but it's always going to simplify. Okay, and so it's going to simplify by a factor of 4, and so that will give you what? Negative 2 plus the square root of 3. These are the two numbers that you always get with tangents. Is 2 and square root of 3. It's just different versions of sometimes they're both negative, sometimes they're both positive, sometimes one's negative, one's positive. Okay, it's always those two numbers that come up. Okay, so really the nasty part behind this is the rationalizing. Okay, especially if you memorize your sine and your cosine with your sum and difference angles. Okay, and there again, I'm gonna be really, really nice and straightforward with you on the test. If I ask you to find the tangent of 165, I would have asked you in a previous question to find the sine and the cosine of 165. Okay, all right, let's do another one. Let me do another angle with you here. Y'all want to do another one? Okay. All right, let's do tangent. Let me think of one here. Which one did we just do? 165. I'll give something that gives me something different. All right, let's do 255. Okay. Yeah, but that would be 255. Okay. All right. So now we're going to cheat a little bit. We're not going to use the tangent formula. We're going to use the sine over the cosine. So we're going to do the sine of 255 over the cosine of 255. Okay. So there again, on a test question, I would have asked you previously what the sine was and what the cosine was, so you wouldn't have to redo it. All right. Now let's go back to the unit circle that I drew with my 15s in there. So let's go to 255. All right. So on 255, all right, what's the sine there? Negative square root of 6 minus square root of 2 over 4. Negative square root of 6 minus square root of 2 over 4. All right, now let's go back to the cosine. All right, cosine of 255 is negative square root of 6 plus square root of 2 over 4. So the square root of 6 was a negative one. Now, when I line these out and multiply this one by the reciprocal of this one, what's ultimately going to happen? Yeah, 4s will go away. Okay. So probably you could actually skip that step and only write the numerators because the 4s are just going to go away. Okay. So negative square root of 6 minus square root of 2 over negatives. Ooh, I messed up. Well, fudge. Markers aren't cooperating with me this morning. All right, here we go. Negative square root of 6 minus square root of 2. Negative square root of 6 plus square root of 2. Okay. All right, right. We're going to multiply by our conjugate. Okay. So let's see. All right, Jake, what's our conjugate? No. All right, there you go. Now, oh, and remember, let's do this. We're going to do this for Mr. Tatum. So if I mess up rationalizing, I can still get partial credit for getting the unrationalized version correct. Okay? You're welcome. All right, let's multiply that. Okay? So on the numerator, we have to FOIL it or just first and last? FOIL it. And in the denominator, we can just do first and last. All right, so here we go. First, what's that going to give me? Yeah, 6. Okay. All right, outside would be positive square root of 12. So it would be really 2 square roots of 3. Okay. Inside, another 2 square roots of 3. Okay. And then last would be a positive 2. So since all of them were negative, you were always doing a negative times a negative. So every sign ended up being positive in the numerator. All right. Now on the bottom, first. All right, now that's going to be 6. And it's always minus on a conjugate. Yeah, 2. The denominator is always going to come out. It might be -4 sometimes. Right. Yeah. So, I mean, sometimes it might be -4. All right. Now, so let's see. The 6 and 2 is going to give you 8. So you get 8 plus 4 squared roots of 3. Y'all see where that came from there? Okay. Over 4. And the 4 is always going to reduce out. So it's going to give you same two numbers again. 2 plus the square root of 3. So you get the same numbers, 2 and square root of 3 on every tangent. Okay. It's just a matter of sometimes that they're negative. Look what the last one was. It was -2 plus square root of 3. This one was just 2 plus square root of 3. Okay, it's just a matter of changing up the signs a little bit. All right, now let me do this for you. Of course, if you're watching the video on this, you just rewind it and go back and get the answers from when we started. All right, but let's get pictures of the tangent problems. I'm only going to give you 4 of them. Okay. Jake, duck so we can see over. All right. Number 6, 18, 20, and 21. I've got them in orange up here, highlighted. All right. So you want to come get your picture real quick? Do that. Yeah. Yes. You probably have it. You may not have got the tangents or the answers.
I don't know. I opened it up and see the picture.
We don't have a book. That's why. It's too cheap to have a book.
All right, I'm gonna move down to the bottom now.